Hello CP Algebra 1B and welcome to our new unit on graphing quadratic equations. It is going to be especially important for you next year, so make sure you pay attention and you will be seeing it again. So first off, we have standard form of a quadratic equation. Just like when you have standard form of a line, there is standard form of a quadratic. We already did some things with quadratics this year, and that's because they follow the following, okay? They look like this: ax squared plus bx plus c, okay? That is the basic form, okay? It's kind of like, okay, if you think of slope-intercept form, y equals mx plus b, well, this is technically y equals ax squared plus bx plus c. Now, a few things going on here, okay? So the basic things to know about. Each of these always has something important to tell us, okay? A, B, and C. They each have something that they do. They each have a job. A's job, okay, is to tell the graph which way it's going to open. So it tells the graph which way it's going to open. If A is positive, the graph opens upward, okay? And more specifically, we'll see later, it looks like a U, okay, opening upward. If A is negative, well, it's going to open downward, okay? So that means it's going to be a frown type of thing. Okay, some other things, if it's a small fraction, okay, we'll talk about what that means in a second. It's going to be very wide, so like a big wide smiley face, either up or down. And if it's a larger number, okay, it's actually going to be narrow. So that's kind of counterintuitive, despite that. So that is A's main job, okay? B's job is a little less, not less important, but B, the coefficient B, is going to be very useful in finding the vertex. Okay, we'll do that in 1 second. That's what its main job is. And lastly, C has a very important job as well. C is the Y-intercept. Okay, which, if you recall to Y-intercept form of a line, that means we're going to have the point 0, comma, C. Again, we will talk about it later. But C, remember, is the Y-intercept. 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 No longer is that B from y equals mx plus b. This is a little different, okay? So this is standard form. Key thing, A always is with x squared, okay? They are always together. Always, okay? B is always with a lonely x, okay? And C always is by itself. It's a constant, okay? So we'll talk about that in a little bit. Right on down into it, okay? Graphing. So really, we can graph these by hand, and it's pretty simple, okay? So we're going to graph ax squared plus bx plus c in this form here, okay? What I like to do is think of this kind of as 1 times x squared plus 6x plus 2, and I like to write down my a, b's, and c's. A is 1, the coefficient, b is 6, and c is 2, okay? If you're having trouble following along, A, B, C, okay? Now, to graph, the first thing we're going to do is find the vertex. Here is where B comes into play, because the equation for this is negative B over 2 times A. What? Okay, that is the big takeaway today as well. Negative B all over 2A. That's how you find specifically the x-coordinate of the vertex. So you plug it all in. We have negative B, which is 6, all over 2 times A, which was 1. simplify that, you really have negative 6 over 2, which is negative 3. Okay, now the vertex is the bottom or the top of the graph. Okay, so we have an xy pair, so this is negative b over 2a. To find the other piece, you have to plug it back into the equation. Okay, so this is where it can get kind of difficult, but again, we'll practice. So the equation is x squared plus 6x plus 2. We found x to be negative 3. The y-coordinate of the equation, we're going to plug negative 3 in for x and in for x. What that's going to look like is negative 3 squared, don't forget the parentheses, plus 6 times negative 3 plus 2. That's going to be our y. It looks scary, but again, it's really not too bad. Just take a deep breath. Negative 3 squared is positive 9 minus 18 plus 2. And after all is said and done, you should have negative 7. So negative 3, negative 7 is our vertex. Okay, we can get to graphing, but actually we have some more. Now this might seem like a lot of work, but it's really not too bad. Find the axis of symmetry. Axis of symmetry is always x equals the x-coordinate of the vertex. So x equals negative 3. Okay, we'll talk about that in a little bit. And the y-intercept, that is C's job. Well, C is equal to, one more time, 2. That means we have the point 0, 2. And remember symmetry. So, what is going on here? We found 3 points, okay? Well, 3 things. First, we found the vertex. Then we found the axis of symmetry. And then we found the y-intercept, all from the formulas. And we plot them. The vertex is at negative 3, negative 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Right there's the vertex. Right there. Okay. If we look at now the axis of symmetry, I kind of have something drawn in here. The axis of symmetry is just this imaginary dotted line. Okay? It's like a mirror, kind of. We'll see that in a second. The y-intercept where it crosses the y-axis. So it's at 0, up 2. Okay, there's your y-intercept. Now here's the thing, okay, these graphs are always symmetric. Okay, so they're always symmetric, and they're always symmetric to the axis of symmetry. So it's kind of like a mirror. If it's on this side, it's going to be symmetric. So 1, 2, 3, 1, 2, 3 to here. And we connect the dots. And we have a nice little U shape. The last little check, okay, A is positive, so it should be going upward. And we have our y-intercept at 0, 2, and it is symmetric. Okay, so that's by hand, not too shabby. One more really quickly. Following the equation, first step again, if you want to do it ahead, you can. Find the vertex, so it's negative b over 2a. Vertex. Well, b is 10, so negative 10 all over 2 times 5. That is negative 10 over 10. That's negative 1. How do you find the y-coordinate? Hopefully someone's like, you plug it back in. Okay. Be careful. 5 times negative 1 squared plus 10 times negative 1 minus 3 equals, this is 5 minus 10 minus 3, which is conveniently negative 8. So the vertex is negative 1, negative 8. If you are like, what just happened? Just take a moment, go back to the previous, and remember, vertex has 2 points. Okay? From there, if you recall, the next step is for the x equals negative 1. What's that? That's the axis of symmetry. Lastly, we're going to have the Y-intercept, which is 0, -3. Again, that comes from C. So there's C. Here's B's game. And again, A. Okay, we got all those points, so let's plot them on in there. The vertex, -1, -8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, our mirror, so to speak, is going to be right on through. And we are going to have the y-intercept, 0, 3, 0, -3, 1, 2, 3. It's going to be symmetric. And we connect, and we'll call it a day right there. Okay, so good stuff. There might be an exit slip at the end of class today. Your assignment is, I'll explain in Google Classrooms, you're going to be looking up examples of quadratic shapes in different scenarios. Once you find them, you will decide what type of A value each would have depending on which way the shape opens. So simply put, if it opens downward, that means A is, I don't know, you have to remember. And if it opens upwards, what it would be there. So some quadratic shapes in the real world. Thanks for watching, and have a wonderful day.